All right, so welcome to test corrections video for question 19. As I work through this, I want you to mostly think about the main ideas used to approach this question, but also I want you to write down the answer as we go. So only part of the goal of this is you writing down the answer for the purpose of test corrections. The other part is for you to understand how to answer this sort of problem in AP Physics. Okay, so the question reads something like this. You should have it in front of you, but below is an image of two projectiles. We have projectile 1 and projectile 2. Projectile 1 goes to a greater height, but projectile 2 has a farther range. Which, if either of the projectiles has a longer time in the air or a greater time in the air, and then justify your answer with a paragraph length response. So this is surprisingly what we would call a AP Physics question that has a title called Paragraph Length Response. And it's exactly what it sounds like. It is a free response question that requires you to reason out in words and with very little math, if any, an answer. You will have a free response question like this on the AP test, so better get used to seeing them now. And this one is one of the simpler versions that we would deal with, and especially this one being kinematics, the odds of having one exactly like this are very low. But it's good for us to understand how to approach these type of problems anyway. So the question, nicely enough, tells us a couple things that are really helpful. One, I don't want to use that color. Let's go with this color. So the question very nicely decides to say, hey, the height of 1 is greater than the height of 2. And we can clearly see that that's the case by how far it goes. And it says projectile 2, so here I'm going to write H. So it clearly has a greater height, but projectile 2 has a greater range. I'm going to call my range capital R, just for range. All right, so we see number 1 has a greater height, but number 2 has a greater range. So what we have to do is we have to figure out why is this the case, and how does that affect to the time in the air. There's a bunch of different ways you can do this. So the purpose of this is you need to suggest an answer. So it's either 1 or 2. Even if you get it wrong, there are odds of you getting points. However, the odds are very slim, naturally, because your reasoning is probably wrong. But that's all right. Better to pretend that you got it right and try to do a justification than to do none at all. You could get points that way. So let's look at what's going on here. So I have two different projectiles. One goes higher than the other, while that other one goes farther. Well, what's different about these two projectiles? Well, once they're in the air, I want you to recall that they are simply experiencing the same acceleration downward. And that is acceleration due to gravity of 9.8 meters per second squared. Both of these are experiencing this force throughout the entire time that they are in flight. All right? So both are experiencing this. So our acceleration is not the same. We already discussed how our height and our range are the same. Lastly, we need to discuss what causes the difference in this problem. Well, if we look down at the beginning, the only thing that can cause the difference between these projectiles is they launched at different angles. So this had an angle that was likely smaller than this outer one. But what does that matter? Well, if I were to redraw that over here, and I were to look at a vector, kind of like we've looked at recently in class, what I hope you would see is that we have to look at its components. Well, why do we look at its components? Well, we look at the components because what the components tell us is some very important information. Because this is projectile motion, you should recall that it's the y component that affects certain things and the x component that affects other things. My range, for example, is affected by my horizontal component, or direction and this is the same thing as my x direction. My height, however, is affected by my y direction, or my vertical direction. Here is my initial velocity v naught for one of them. This guy down here would be my x component, so v naught x, and here we would have v naught y. Well, assuming this velocity is the same, let's pretend this is this top one here. And then if I have another one that's at a lower angle, even though it's pretty much the same size, this would be another v naught, I want you to see how different they would look. Just by changing my angle that my projectile was at, my initial y velocity looks very different than my initial x velocity. So this was the main thing you should have seen at first. For me to have a higher height, which one needs to be bigger? Well, I hope you can tell that this one has a higher y component. So my y component is bigger, but my x component is smaller. That explains my range. This guy here has a smaller y component, but a bigger x component, while number one has a small x component and a big y component. And my question is about time. So what affects time? Well, think about it. Time in the air. For you to have an object in the air the longest amount of time, which way should you throw it? If you could throw it as hard as you can, should you throw it sideways, or up at an angle, or up at a little bit of an angle, or straight up? This is something we specifically talked about in class. If you throw something up in the air, straight up, that is when the time is going to be greatest. So we have to figure out in which scenario is my time going to be greatest. And sure enough, it's going to be in the one with the greater amount of its velocity in the y component. And so our answer needs to be projectile 1. I know that was a lot of reasoning just to get to projectile 1. But here's why I had to do that. Because what we need to do now is we need to go back and to justify our answer, go through our exact same reasoning. Well, how do we know it's projectile 1? So on these paragraph length questions, you can actually write a paragraph if you'd like to, symbol for a paragraph, or you can write it in bullets as long as it makes sense. So projectile 1, boom, we start with our answer. But here's what we need to do. We need to say an answer. We need to give our first thought, so the first thing that brings us to our answer, to justify. So we have to have a fact or physics concept. Then we have to apply that, and then our application of that should bring us back to our answer. And I'm going to show you how that looks on this problem. Projectile 1. Well, time. What's time dependent on? Time is dependent on, well, what changes here? It's not dependent on the height necessarily, or the range. Rather, it's dependent on everything in the y component. So time is dependent on the y component of my motion, all right? But realize the thing that affects my y component the most is my initial velocity. So this is a physical fact. This is a concept we have discussed. Remember when we had the hunters who shot at different levels? We'd have the height that mattered. But then we also said if we were to shoot down to the ground, or if we were to drop an object sooner, it would fall a lot faster than would an object not shot at that direction. Just think about it. If you throw something to the ground, it's going to beat something that you simply dropped, because you're going to give it initial velocity. So the more motion I have upward, the longer I'll be in the air. So time is dependent on the y component of my motion, and we can specify especially the initial y velocity. So this is a physical fact, but you haven't explained how this tells you projectile 1. We have to relate it. So that was our fact or physics concept. Now let's apply it. Projectile 1 has a greater y component velocity, and also you could say and height, than projectile 2. And for the purposes of this, I want you to realize, even if we were to ignore this, if we were to say, well, let's say both of these had an initial velocity that started up here. I want to know which one would get to the ground first. Well, this one would. I hope you see that, because remember our hunter problem. If it was shot down horizontally, like this would be at the very top, the one with the smallest height is going to get down there faster. If it takes the same amount of time to go here to here as it does to go down, then projectile 1 has to win, because its second half is longer than projectile 2's, so is its first half. So projectile 1 has a greater y component velocity and height than projectile 2. And because that's true, we have to tie it back to our answer. Therefore, time to hit the ground is greater for projectile 1. And you're like, how could I get a paragraph out of this? Well, look, 3 sentences. So the way I added points for this was I gave you 4 points if you said projectile 1 was correct. On an AP Physics test, that is actually a little generous. So most of the points will not come for your answer, but rather for a justification. If you said time is dependent on the initial y velocity or something to do with the y component, I gave you some points for that. And then if you said projectile 1 has a greater y component, so if you made the connection that projectile 1 has a greater y component, I gave you 2 points for that. And then if you tied it all back together, I gave you another point. And then if you made some sort of reference to the height, I gave you that last point. So I want you to completely answer this. You can even put it in your own words if you'd like to, but I want you to realize this cycle that we have to make. We have to answer the question, back it up with a physics concept, apply it to how it relates for this problem, then answer the question. If you want to see if you understand this concept, what if I asked you instead, which one has a faster horizontal velocity? All right, so you can answer that question if you would like to also. The main ideas here are what we're studying right now are really the directional motion or the components. Components was the main thing I was looking for, and then that you applied it in here. Okay, go ahead and correct that, and I want you to write this down somewhere useful. Remember, paragraph length response can be a paragraph, kind of like this, or it could be bullets, where you just bullet some facts. Time dependent on y component, initial y velocity. Projectile 1 has a greater y component than projectile 2, therefore projectile 1 has the greatest time to the ground. All right, have a great day.